In this video, we'll solve grams to grams stoichiometry problems from start to finish. I'm going to show you the full method and explain why each step is needed. Now, just a reminder before we get going into some examples, all stoichiometry problems use the stoichiometry roadmap shown here. And so let's just go through it quickly. The first thing that we need in terms of stoichiometry is a balanced chemical equation because everything hinges off of that. Once we've got that, our problem is going to, in grams to grams stoichiometry, it's going to give us a known value in grams. We need to convert that into moles using moles is mass divided by molar mass. Okay. Once we have that, we can use our balanced chemical equation to come up with our mole ratio to find the moles of our unknown substance, which we can then convert back into grams using mass is moles times molar mass. So if you follow this roadmap for every single grams to grams stoichiometry problem, you should always come out with the correct answer. Let's jump right in then to our first example. So our first example says we've got the action of dilute nitric acid on copper is represented by this equation here. Now you can already see it is balanced. So step one is already done in Stoich. Then we need to find what mass of copper is going to be required to react completely with 250 grams of nitric acid. So let's get out our handy highlighter and highlight that we're looking for the mass of copper, and copper's right here in our balanced chemical equation. And then we are given 250 grams of nitric acid. So that is right here in our balanced chemical equation. It's always helpful to get the highlighter out because then it helps you to focus on what molar ratio you're actually using. Now, we're given information about nitric acid in grams, and we need to find moles. So let's do that step first. So for nitric acid, our moles is going to be mass divided by molar mass. We're given 250 grams, and the molar mass of nitric acid is 63.02 grams per mole. Okay. Doing that calculation gives us 3.9669, so on, moles. Do not round off here because if you do, you will end up with rounding off errors and your answer will be incorrect. Okay, so now we've got this one here. We need to find our mole ratio to find the moles of our unknown substance. So let's go to our balanced chemical equation. And we know 8 moles of nitric acid require 3 moles of copper. So we're going to go 8 moles of nitric acid to 3 moles of copper. And then on the other side, we need nitric acid on the top, and that was calculated here. So I'm going to put that 3.9669 moles of nitric acid on the top here. Just making sure and double checking that if I've got nitric acid on the top there, it's on the top there on that side of the equation too. And then we're trying to solve for moles of copper, and copper's on the bottom on both sides. So now we're going to cross multiply. So we're going to end up with 8x is equal to 3 times 3.9669. So that is 11.9009. And then we're going to divide both sides by 8 to get our value of x, which is the moles of copper. So x is 1.4876, so on, moles of copper. Again, do not round off yet. We're not done. And that is going to lead to rounding off errors if you do round off here. All right, so one last step we need to do down here to go back to grams because the problem is asking us for mass. So we're going to do mass is moles times molar mass. So we've got our 1.4876 moles. And then the molar mass of copper is 63.55. Now be careful here. This is the molar mass of just one single copper, okay? Do not include the 3 in here again because you've already used the 3 in your molar ratio, and adding another 3 here would put your answer off by a factor of 3. Okay, so doing that calculation and noting that we have 2 significant digits here, we want to answer to 2 significant digits in our answer, which is going to give us 95 grams of copper. Let's try one last example. So this one, how many grams of chlorine would be obtained by heating 70 grams of manganese dioxide with an excess of hydrochloric acid? So let's get out our highlighter again. We're looking for grams of chlorine. And so that's here in our balanced chemical equation. Now you can see it's already balanced again for us. So we don't need to do that step. And we're given 70 grams of manganese dioxide, and that's right here. So this problem has a reactant with a product. The last one had both reactants. Really, as long as you're given one quantity, you can find any of these other quantities in the balanced chemical equation. Okay, so step 1's done. We've balanced the equation. We need to do step 2 now, going from grams to moles of our known substance. So that's the manganese dioxide. We're just going to write that over here. We're going to do moles as mass over molar mass. The mass given is 70 grams. And then our molar mass, if we calculate that out, is 86.94 grams per mole. So doing that calculation gives 0.8051, and that's moles of manganese dioxide. Okay, next step then, we need our mole ratio to find the moles of our unknown. So looking at our balanced chemical equation, it is a 1-to-1 ratio. So you can still set up the ratio, but know that the number of moles of MnO2 is also equal to the number of moles of chlorine gas because it is a 1-to-1 ratio. But let's set up the ratio anyway, just so we can see that. So 1 mole of MnO2 produces 1 mole of Cl2, and we have 0.8051 moles of MnO2. And we're looking for X moles of Cl2. So doing our cross multiplication, we end up with the 0.8051 moles of chlorine. Okay. Last step then, we need to convert back to grams. So to do that, we're going to do mass is equal to moles times molar mass. Now, remember here, chlorine has Cl2, so we need to take the molar mass of chlorine and multiply it by 2. And so we've got 0.8051 here. And then the molar mass of Cl2 is 70.90. And we've got 2 significant digits here, so we're going to round our final answer to 2 significant digits, which is 57 grams of chlorine. And so you can see, if you follow the stoichiometry roadmap, you're going to come out with the right answer every single time. In the next video, we're going to look at some of the most common mistakes students make in stoichiometry and how to avoid them. That video is linked on the screen now and in the description below. Go check it out, and we'll see you there.